Today, we're going to talk about just what is the DesignStudio Microarray Assay Designer. We'll design an iSelect custom array. We're going to evaluate that design, and that's an iterative process. Finally, we'll place the order. Then we'll look at how to design a commercial plus array, that is, add-on content to an existing Illumina array. And we'll look at some common roadblocks in the design and ordering process. So what is the Microarray Designer? Because the whole name is a bit of a mouthful, we'll refer to it mostly as Microarray Designer moving forward. It's an online tool that you can use to design and order both custom and semi-custom genotyping arrays for any species. It provides a score for each target submitted, and it indicates markers with warning and critical error codes, and we'll get into that in more detail. It also cites Illumina validated markers, which is really nice to know that this marker has been designed and validated. And for some of you may know that the Microarray Designer replaced what was the assay design tool, and this is really a streamlined tool now. Overall, the Microarray Designer assists with design, and our goal is for you to have a successful assay. Some of the features are, one file submission is sufficient if the design is successful and if you approve the design. Previously, you had to submit preliminary files and then combine them into a final file. This is no longer needed. One file submission will suffice. Normalization bins are emphasized in the design summary, and normalization bins are used by the eye scanner for red and green color balance during scanner. Targets with critical errors versus warnings are automatically excluded from the design and reported in a separate file. The warnings and errors are simplified, and again, we're going to go over that in more detail. And finally, you can drag and drop to upload your input files. But before we get started, let's talk about some of the terminology that we use. Marker, locus, target, these all refer to the polymorphism in the genome. So a SNP, or an indel, is designated within brackets, shows the two possible alleles for that locus, and those two alleles are separated by a slash. What we don't see is that when we submit a sequence for design, you will include 50 nucleotides on either side of that SNP. When the probe is designed, it is 50 nucleotides, and it is the sequence adjacent to and ending in the SNP as seen in this diagram. The bead type is the probe and the Illumina address used to identify the bead type on the bead chip, plus the bead is called the bead type. Most markers require one probe, some require two, and because of that, the number of bead types in your final design is always going to be greater than the number of markers. Bead types are combined into what's called the bead pool. You'll notice for each bead type that there are multiple beads, and the beads in this tube are all the same. They all have the same probe oligo on them. Each of these bead types up to, for a custom design, 700,000, are combined into a single tube. This is called the bead pool, and the bead pool is applied to the bead chip. The beads settle into these spaces on the bead chip, and the beads randomly self-assemble. And finally, this is what the bead chip looks like once the beads have been loaded on. Let's just quickly review the workflow. When you want to submit markers for scoring, you will use input files, and we'll go over the different types of input files in detail. You'll select the assay, whether it's HD, HTS, or XT. You'll configure the design, and that includes selecting the species. You'll upload those targets using the input files. You'll review the design, and again, this is an iterative process until you're satisfied with the content that you're including in your custom array, and then you order the design. So how do we get to the DesignStudio Microarray Assay Designer? This is through the Mylllumina login. Once you log in to Mylllumina, you will go to the DesignStudio Microarray versus DesignStudio Sequencing. And here on the home page, you'll see your most recent designs and the pertinent information for those. You can start a design by choosing Start Design in the header or by clicking on Start New Design. When you do that, you'll come to the Design tab, and we'll go over how to create the design in a moment. But first, I wanted to point out some features on the Design tab. First, we'll look at the Help button. So if you click on this question mark, you'll be brought to a page that describes different parts of the process. First, getting started gives you an overview of the design process and some of the features of the Microarray Designer. Then the steps for creating a design. Again, it points out the different assay formats. It gives you a list of your designs. And it shows you the option of downloading the design files. Finally, instructions are provided for how to place your order. And again, this is from the Help button, which is the question mark. So now we're back to the Design tab. You can also view your designs as a list. And each of these columns are sortable, both ascending and descending. Choosing how to sort your files can make it easier to find your design of interest. You can sort by species or even the date. If you hover over the design name, any comments you've made in the description field will show. That will help if you've got multiple designs submitted for a single goal of a custom array. You can also search. So say you know your design is human, or if you search by the design name, you can also search by the design ID. Once you find your file, if you click on it, it will bring you to the last step, or I should say the next step that needs to be done for that assay design. In addition, from this list, you can choose download files, and this will give you the option to download the files that are associated with your design. But also we see here, looking for your manifest files, this will bring you to where the product files can be found for your custom array. Now these product files are what are produced after the assay has been designed, produced, and shipped. So these files are accessible from the custom products homepage. You need to provide two pieces of information. The first is the sales order number or the PO number, and then second, the barcode number. And we do recommend using the barcode number, the part number. Let me start that over again. We do recommend using the part number because this is important rather than the barcode number. Once you enter that information and access product files, you'll see the .bpm manifest that's used to create the Genome Studio project, the .csv file, which is the readable version of that manifest, and the XML product descriptor file. So if we go back now to the Start Design tab, let's start a design. We have options of iSelect, which is fully custom, and iSelect Plus, which adds custom content to either a previously designed and produced iSelect array or a Commercial Plus array. The Commercial Plus is where you can add custom content to an existing standard commercialized Infinium array. But do please note that if you have an existing Commercial Plus that is add-on to a previous standard array and you want to add more, then you need to choose the iSelect option. For Commercial Plus, the first thing you'll do is select your base content, and we'll go into that in more detail a bit later. So getting started, which format to use? We have two main choices, and they're based on the number of targets that you want to look at and the number of samples you'll be processing. So for HD and HTS, you'll see there is a difference in terms of the number of targets. There's only one species per design, and the minimum order is 1152 samples, and you'll see that both HD and HTS will be designed as a 24-sample bead chip. The XT, on the other hand, is suitable if you're looking at a very targeted panel, but you want to be processing many samples at a time. So this is a high throughput, and it's a more targeted content. One of the slick things about the XT design is that you could include multiple species per design, as long as you have at least 20% per species. And you see here, this is a 96-sample bead chip format. I also want to point out the conversion rate. When you are designing a custom assay and you finalize it and submit it, of that content that you've submitted, of the number of targets that you've submitted, we guarantee that 80% of those targets will be included in your final content. That is, they'll be accessible on the bead chip and they'll be included in the manifest. For the HD or HTS, that number is 80% guaranteed conversion. And for XT, that conversion rate is 95. And I bring this up because we're going to talk about this a little bit later. Infinium XT is available by inquiry. So if you think you might like to plan an XT project, please contact your local account manager. Okay, so now let's get down to it. Let's design a custom array. So first we want to select the assay. And in this case, we're going to choose iSelect and fully custom. We're going to add a design name, and you can add notes in the description field, and select Next. On this page, the next thing we'll do is confirm the name of the design, and we'll look at the status. So status right now is created, but nothing else has been done. The first thing we're going to do is add our species, and in this case, we're going to choose Homo sapiens. Add species, and click Next. And in this next screen, you'll see that Homo sapiens is displayed. If you want to choose that species, you can X out this box, and it will take you back to choose a different species. Click Next. And now we're going to upload our files. As I mentioned, there's a number of different file types. So let's look at what the available templates are. There's 6 available templates. The first 3 you see here are for human only because these reference Genome Build 38 in DesignStudio. The second 3 can be used for submitting content for any species. Oh, and it's not human only. I mean, it is human only, but the other 3 are human as well as other species. So how are we going to choose the right format? There's several different ways to specify the markers of interest. So let's briefly go over the different file types. An identity list is probably the easiest if you have RSIDs from dbSNP. You can also choose a region of the chromosome by specifying the chromosome and a start and end coordinate, and you can specify a gene name from RefSeq or Hugo. Another very common input file type is the sequencing list, and it can be used when you're working with non-human species or if the markers are not annotated in dbSNP, such as markers from private databases or from sequencing data. In a sequence list, you choose your markers within their sequence content, and you remember we said you need to include 50 nucleotides on either side of your SNP, indicated in brackets, and you'll provide additional information if you know, such as the genome build, the chromosome, and the coordinates, and if you have even strand information. An existing design file is great because you can use this if you are including markers that have been previously designed and, remember, produced by Illumina. So you'll simply make a list of the Illumina IDs, and these can be found in any manifest, whether it's custom or standard. And this will guarantee that the exact same probes will be created as in the original design, including on the exact same strand. The output of submitting these input files to Genome Studio is called the score file. When you get that score file, you can use it to then review your design, review your targets, make changes to your targets, and then resubmit that score file. When you do, you just have to remember to delete the header, but it's nice to have all of that information in the one place and then use it for reviewing and then resubmitting. Let's look at just a few examples of the more common file types. So for sequence, you see there's quite a few columns. You need to include the locus name, the target type is either SNP or indel, the sequence, and if you have it, the rest of this information will be included in your manifest. Some of these columns are required, but not all of them. The identity file, again, is just simply a list of RSIDs from dbSNP, and the existing design file is the Illumina ID in the format that you see here. So it is possible that you can experience some errors when you're uploading these input files. Some of the reasons have to do with just simply the formatting of the CSV file, and those of you who've used a sample sheet to create a project in Genome Studio may have experienced some of these formatting issues, such as spaces or commas in the file, or blank lines or blank cells under the column. The easiest way to determine whether you have these kinds of issues is to open your CSV file in Notepad and take a look at it. You can also experience issues if the language setting on your computer is other than US English. And then finally, if the file is not saved as a CSV file, you will not be able to submit it. As I mentioned, you can submit a modified score file, but just remember to delete the header, because if you don't, you will get an error. Also, if the file is too large, that is, it's over the maximum of 700,000 markers for a custom array, then you will get an error message. The best way to avoid some of these formatting issues is to use the templates that we saw listed previously. So now we're going to create our input file using our file type of choice. Today we're going to choose an identity file, and then we're going to use the drag and drop feature, and we're going to upload the file. Once the file is uploaded, we can see here, we can confirm the file type and the file name, just to confirm that we did upload the correct file. Choose Submit for Design, and this is the screen you'll see while you're waiting for your assay to be evaluated by DesignStudio. When it's finished, you'll get the message that your design has finished successfully. Once that design is finished successfully, you will receive an email that gives you a link that does go back to DesignStudio, and it also lists the failure codes, both the critical failure codes and the warning codes. So let's look at these in a little bit more detail. If you look on the right, the warning codes are given the numbers in the 300s and the 600s, and these, any target that has a warning code can still be included in your content. The fact that it has a warning code indicates that there may be a lower probability that that probe can be successfully used, but it still can be included. A lot of these you can see can be modified, and hopefully you can eliminate some of these codes. Critical failures, on the other hand, cannot be included in the design, and in fact are reported in a separate file called Excluded Content. And you can see all of these codes are in the 100s. So some of these are easy to fix, such as flanking sequence is too short, so you'll just need to go back to the sequence that you're looking at and add more sequence on either side. Another is perhaps that degenerate probes have been used. And so if you were to go through and remove those degenerate codes, then you'd probably be able to submit your sequence. Alternatively, if you have degenerate nucleotides in your design region, you may not be able to submit it because you can't just fake it and say, I'm going to give it a certain nucleotide, because then your probe won't bind if it's not the right nucleotide. So to summarize here, warning codes can be included, critical failures cannot. If we go back to the email and click on the link to DesignStudio, it will take us back to the same page that we saw when our design was finished. Let's choose Review Your Design, and what we'll see on this page, on the summary page, is the name of the file, the name of the design, and the status, which says now it's ready to order. And the fact that it says ready to order means that it was successfully designed and there are no error codes. So now we can either take a look at the design files or we can upload new targets. So as I mentioned, as an iterative process, you can say, okay, this is great, I'm glad that these targets design well, but I have a few more I want to add. And so you can use that using this upload new targets feature, and you'll go back to the same page where you're going to select an input file type and download that file. So back to the summary page, we can use the download file button, and it will bring you back to the list of your designs. So here's our design, we love arrays, and we can click on download files, and now you'll see the different files. We have the score file, the excluded content. Here we see an identity error file because we submitted an identity file. So this file type is specific for having inputted an identity file. And what's really nice, and a new feature of DesignStudio, is that it saves a backup of the file that you submitted. So say you're in the process of designing a custom array and you have multiple files that you may have submitted or multiple files that you considered submitting, DesignStudio will save those input files as a backup. So if we look quickly at some of these file types, the identity error file list, you remember the identity file is just the RS numbers, so it's listing the RS numbers and the failure code. So if it's not found, it may be that this RSID was from a previous version of the genome build rather than 38. And if you searched by that chromosome and coordinate, you may find a new RS number. Or if you use that RS number in dbSNP, you could find the updated RS number. As I mentioned, the excluded content cannot be submitted, and it gives the reasons why. So what's in the score file? So first is your design score, and it's the probability that the probe will be successful in your assay. A validated, an Infinium validated probe will give you a score of 1.1. And while there isn't a specific cutoff, you can see that you can see a cutoff sometimes for scores. Low scores can be caused by things like the possibility of forming secondary structures, or the marker is in a duplicated or repetitive region. As I mentioned, the warning codes can be submitted. The critical error codes cannot be submitted, and these will give you, for sure, low scores. And so to reiterate, critical errors cannot be ordered, warnings can be. So if we look at the score file itself, we're going to do a quick review of the score file. So first you'll see the header that gives the name and the platform and what kind of file it is, the number of markers, the number of bin targets, and you'll see here that the number of bead types is greater than the number of assays. What we're going to do is we're going to set a filter on the column header row. And first what we're going to do is filter by final score. So we're sorting, and we see that while most of the scores are around 0.4, there are 3 that are considerably lower. So we could choose to remove those targets. Next, we can look at the failure codes to see if we have any issues. So we see here only the warning codes, and many of these can be fixed and removed. If we're going to resubmit the file, remember we need to remove the header. Okay, now this file would be ready to resubmit. So to summarize, when we look at the score file, we're going to set a filter on the column header row. We're going to sort by the final score and decide whether to keep markers with low scores. Then we'll sort by failure code, review any markers with warnings, and decide whether we can fix them and to keep them or whether to remove them. It's good to create a list according to your experimental needs. You might take into consideration spacing, depending on your experimental goals, whether you'll be doing imputation with tags or whether you're looking at minor allele frequency. And once you've evaluated your content, you may need to score additional markers. You can score and combine multiple score files generated from different input file types, and we'll look at that a little bit more. But finally, if you're going to resubmit the score file, you need to delete the header section. So let's evaluate our array design a little bit more. So we see here, we have the number of targets submitted, we have the number of targets designed, and the number of targets excluded. So we mentioned the color normalization bins A, B, and C. And for each of these bins, the quantity must be 0 or greater than 100. Except for bin C, which has to be greater than 100. If that's not the case, if there's a problem, then we'll see why the design cannot be ordered. In this case, the normalization bin count doesn't meet the minimum requirement of 100 for ordering a Homo sapiens. Also, the total bead count does not meet the minimum of 1,000 required for ordering. What's a way to get around that? Say we have 50 in bin A and 75 in bin B, and otherwise we like our design. There's a way to force Infinium 1 such that you'll increase the number of targets in both bins A and bin B, and that is to submit your SNPs in a sequence template and take advantage of the column called Force Infinium 1. So for a number of probes, and you may have to do this a couple of times to make sure that you do get greater than 100, you'll change Force Infinium 1 from false to true, and this will increase the numbers in your bins A and bin B. And the reason for this is because bins A and B are the two different colors. And again, this is used by the iScan for color normalization during scanner. Bin C are the probes that are the Infinium 2 probes, and this means that there's just one probe that's used to target that probe. So bins A and B, Infinium 1, 2 targets. Bins A and B are the two different colors, red and green, and bin C is Infinium 2 type, which is one probe, and so this should have the majority of your targets in it. Once we reviewed the content, made sure that we have the expected numbers of targets in bins A, B, and C, we can then finalize and submit your order. Here you have an opportunity to change the file name. Say you've been submitting multiple files, you've given them different names to try to distinguish them as you create your custom array. Now is your opportunity to make a formalized name for your custom array. You want it to be brief, but you also want it to be specific. So now, once we can finalize the name and place the order. So there's a couple of different steps here, so which will get pricing, you'll be asked for your customer information, et cetera. So let's look at that quickly. The first thing you'll do is submit the number of samples. and remember the minimum is 1152, then this will bring you to the page where you're going to get pricing and packaging options. So here, because we see that the number of targets for this array was between 3,000 and 90,000, this will choose the HD format of the 24 sample bead chip. And because of that, it will also provide the catalog number for the iSelect HD custom bead chip, which is 24 sample and 1152 samples. So say you wanted to do 3,000 samples, then the number of kits here would be modified. So now you've got your price per sample, the format, the number of samples, and the bead chip kits that will be required to process these bead chips. We can add this to our cart. And once again, we've confirmed the name of the array and the kit. We can check out. So here, just like with any online order, you'll need to provide your customer information, including your phone number. On the next page, it's more about accounts payable and billing. You'll enter an email, and if Illumina needs to contact you for credit approval or with questions. We can continue to reviewing the order now. We've got the billing address and the shipping address. Again, we've got the estimate. There are several delivery options. If you want to delay your delivery, you can state that here. The current expected delivery is about 6 to 8 weeks now. You can choose to not receive partial shipments, or if you don't check this, then you're saying it's okay for me to receive partial shipments. I don't need to receive all of the bead chips at once. So now we'll continue to pricing now that everything's been confirmed, and we can continue to check out. Just a few more things now. So now we have to pay for our order. The options here are purchase order or credit card. The maximum amount for a credit card order is $10,000, and most likely your custom array will be more than that. So now you'll have to include a PO number, and then you'll need to accept Illumina's terms and conditions. And finally, we can place our order. Let's look at a few of the problems when we're actually creating our design. So what happens if we upload the wrong species? So in this case, we want to design a chicken array. So we have uploaded, so we're in the species type, we've chosen chicken, but in fact, we've uploaded a file that includes, it's a sequence file, and it's for zebrafish. So now we can see that the file's been uploaded. It doesn't really say, it says sequence and then a species, which, wait a minute, is not chicken, but what happens if we submit the design? So what we get is for we're not chicken, is the design is ready to order, even though we uploaded the wrong species. So I'm telling you this as a tale of caution. So make sure that you're uploading the correct species. On the other hand, if you choose the wrong file type, so in this case, we're choosing, we want to create a design for Tasmanian devil, but in fact, we've uploaded, so we wanted to choose a sequence design, but in fact, we uploaded an existing design file, and we can see now that we get a hard stop error, that the imported file does not match with the file template. We talked a little bit earlier about combining lists. So for an iSelect, you can score the lists separately. You can submit different kinds of lists, then you can combine the score files and resubmit. For Commercial Plus, and we're going to see this next, in fact, is when you're creating a Commercial Plus design, you don't have the option to upload additional input files. You can only do one finalized input file. So you're going to score the files separately and then combine them to submit a single input file. Whereas for a regular custom array and iSelect fully custom, you can upload as many file types as you want, and they will be combined for you. So let's look quickly at designing a Commercial Plus array. So we'll choose this option in the Start Design page. And again, note, if your Commercial Plus array is the base, you need to use the iSelect button. So now we're going to choose our base content. And there's a couple of different ways we can do that. First, we'll see a list. And we can choose from that list by scrolling, or we can search by maybe it was 8 sample or the name included LD, or we know it's a bovine. So if we search bovine, we now see bovine LD. So as I mentioned, you can use the scroll bar to find your base content of choice. Today we're going to choose core exome 24 version 1.1. And I want to note here that when you choose a particular commercial array as your base content, you will see the minimum bead types required for add-on, as well as the maximum number of beads for add-on. In this case, the minimum is 1,000 and the maximum is 100,000. And again, it confirms that it is Homo sapiens. So when we say use base content, and now you can give your add-on content a design name. Actually, this is for your array, your Commercial Plus array, and then click Next. So you'll see here that it automatically populates Homo sapiens because that's the species of your base content. And then we'll click Next. Now we need to add the input file. We need to add the content. So in this case, a file has already been uploaded. It was an identity file. But we now reviewed that file, and we are going to upload a modification of that file. If you remember, I said you can't do multiple iterations for Commercial Plus. In this case, when we upload a file, it's going to replace the previous file. So we can't do multiple files for Commercial Plus. There needs to be just one additional file added, and that's your add-on content. So what if there's a problem? So in this case, we submitted for Commercial Plus over 3,000 targets. When we look at the design summary, we're seeing that there were only 95 of these targets that were designed, and then we see that over 2,900 were excluded. If we look at the box that says design cannot be ordered, we'll see that, again, it's the two reasons. One, the normalization bin doesn't have the minimum of 1,000, and the content doesn't have the minimum of, the bin needs to have a minimum of 100, and the total bead count needs to be greater than 1,000. So if we look at the excluded content file for this design, we'll see that for the other 2,913, that the locus name is duplicated in the base commercial content. So what happened is the file was submitted with targets that were already on the base content. So now if we have reviewed the summary, we see we have the number of required targets in each of the bins and the number of required total bead count. We can then proceed to order. This is the same screen we got before. We get to finalize the product name, and then from here on the ordering process is the same. So a frequently asked question. You remember when we were discussing the different types of assays, and I said that for the HD or HTS, that the conversion rate was 80%. That is, 80% of the targets submitted to be produced will be included in the final content. What if you have some SNPs, some targets, some probes that are critical to your assay? A way to ensure that those probes are included is to create a duplicate assay. And this is done using a sequence input file. So you'll create a duplicate entry in the scoring input file, so create a new row, rename the locus name so it's unique. So DesignStudio cannot process duplicate locus names. So we have to give it a different name, and you can either add a suffix to the end or a prefix to the beginning. We do recommend including the name of the original locus so that you'll be able to determine the duplicates. You can submit this file for design. If you have an identity file or an existing design file, you'll first need to score that, and then with that score file information, create the sequence input file to make those duplicate assays. Again, you're modifying the name, and especially for RS numbers, you can't have duplicate RS numbers, so you would, at the beginning. So it's very important if you're using an RS as the locus name that you include a prefix for the duplicate name. Once you score that file, you can then submit, and now you'll have duplicates of your more important probes. So to summarize what we've talked about today, we've looked at the features of and the navigation in the Microarray Designer. We designed an iSelect custom assay. We evaluated that design, and again, I want to emphasize that that's an iterative process. You just keep looking at the designs, making sure all of your targets are included, making sure that your targets meet your experimental needs. We showed you how to place an order. We also talked about designing a commercial plus array because there are some parts of that process that are different from designing a straight, fully custom iSelect array. And finally, we talked about some common roadblocks in the design and ordering process. I'd like to direct you to a couple of important resources. When we provide the product files for a custom array, we do not provide a cluster file. So clustering on your own samples is going to be necessary for a custom array, and it will produce the most accurate data for your project. This webinar that I describe here is targeted at new and intermediate users, but we find that even more experienced users find this to be a very helpful resource. Additionally, we have a tech note that goes step by step through those instructions for creating a custom cluster file. I want to give a plug to our next upcoming webinar, which is Infinium Methylation, an Introduction to Analysis, presented by our colleague Neha Kubal. And it's an overview of doing the Infinium methylation analysis. Finally, I'd like to point out some resources. So we have a number of bulletins that are very useful, especially when talking about things like strand designations in a manifest. We have live support technical live webinars. Some of the more useful ones are Infinium best practices, also troubleshooting Infinium data in Genome Studio. We also have online trainings. For those of you who may be new to Infinium, these trainings really provide a great basis for moving forward. And finally, we have a kit selector, which helps you choose the best kit for your assay. Again, it's the same kind of thing with DesignStudio, where you want to look at the number of samples you want to do. You want to look at whether you're doing whole genome or targeted content, and how many targets you want to be looking at. So thank you for your time and attention today.